Imagine a building that doesn't fight an earthquake but gracefully sways above it. That's not science fiction. It's the reality of seismic base isolation, and at its heart is a brilliantly simple component: the isolation rubber bearing. The old paradigm was to make a building stiff and strong enough to resist seismic forces, an expensive, often losing battle. The new paradigm is isolation, letting the ground move while the structure above moves much less. Here's how it works. A typical lead rubber bearing is a layered cake. Thin steel plates provide vertical stiffness to carry the building's weight. Between them, thick layers of high-quality natural rubber give the horizontal flexibility, allowing the bearing to deform several inches or even feet. At the center, a solid lead core is the genius element. It yields plastically during an earthquake, absorbing and dissipating massive amounts of seismic energy as heat. This is called hysteretic damping. The system is installed between the foundation and the superstructure, creating a flexible interface. When the ground shakes, the isolators deform, and the fundamental period of the building is lengthened from, say, 0.5 seconds to 2.5 seconds or more. This moves the building's response out of the most dangerous, energy-rich range of the earthquake spectrum. The result? The peak acceleration felt by the structure can be reduced by up to 80%. The building sways gently as a rigid body, drastically reducing interstory drift and preventing non-structural damage and collapse. A pro tip for designers: the isolation system's effectiveness is entirely dependent on achieving this period shift. You must accurately model the stiffness of your bearings in your analysis software. A common mistake is overlooking the strain-dependent properties of rubber. Its stiffness changes with the magnitude of displacement. For large projects, always use bilinear or multilinear models, not just an average stiffness. Also remember that while the superstructure sees reduced forces, the isolators and the foundation must be designed for the full displacement demand, requiring a clear moat gap around the building. In conclusion, seismic isolation rubber isn't just a product. It's a fundamental shift in seismic design philosophy from resistance to mitigation. It allows engineers to design for life safety and immediate occupancy with incredible confidence, protecting both the structure and everything inside it.